Alright, so hi there and welcome. I'm going to do a technical demo. I'm going to show two CTF challenges. These are cybersecurity challenges. This is a few months back, so I'm trying to remember a little bit. This is all safe and legal, nothing nefarious ever. These are all just hacker game challenges meant usually run by the universities and stuff, but they're meant to make coding fun and test the boundaries of code and challenge our learning and show us how to do things properly. I'd like to quote one of my favorite speakers, Jason E. Street, in saying, "I'll never pwn your systems unless first you grant me permission and second you pay me to do so." But so this is the first challenge I'm going to show. This is called random-rsa. This is what they give us. This is a time challenge. They basically give you 2-3 days or weekend to do it. So some of the code's kind of scrappy. This is everything they give you, and basically there's a flag string here. And when on the server they have the actual flag, and there's some way to break this program and reveal the string that they're not really intended to, but it's has a broken design. So I'll show that. This is what I came up with. Basically, we discovered that weak random number generator in the wild. This was used for two-factor authentication, and I guess with I think 624 sample random numbers generated, you're actually able to predict all future random numbers generated. And so, with some trial and error, this is what I came up with. This program talks to the server and reads those numbers and then creates a what I call a reverse random number generator. Kind of scrappy code, but this is how it works, and I'll show that now. So on the left is I'm going to run the server, which just runs that Python program on the socket. And then on the right is the solve. It looks at those numbers, gets the or figures out the two prime numbers, and then is able to decrypt the string, and that's what it revealed. So that's the first one I was going to show. That's random RSA. The next one I was going to show is lottery. This game, players purchase tickets. You get to pick 6 different numbers between 1 and 70. You get to pick how many tickets you buy. Each ticket costs $1. And then you get a prize if you get at least 2 of the matching numbers. This is everything they gave us. This is the program. This is the prize winning. So that's if you get 2 numbers, 3, 4, 5, and 6 numbers. And it's saying if you could purchase some amount of tickets and then consecutive rounds of the lottery, if you could somehow make money. So first I'll show the game. So this is what that looks like. Let's say we want to buy 1 ticket, and let's say we want to buy 5, 7, 13, 35, 21, and I don't know, 27. Up, I didn't win. That was the actual draw. I lost $1. But what I did was what they're trying to show. This is what I came up with. A few different things. I think I discovered I was trying different things at it, but there's a thing called finite projection planes. The math is honestly a little above my head, but reading on the internet, I was able to discover there's a certain, I think it's called combinatorics, probably pronounced that wrong, but there's a set of numbers that you could pick that basically gets every combination to the best like possibility. And so basically, if these are the lottery ticket numbers that you want, 35 tickets gets you at least a two winner every time, I believe. And I think it was by the seventh try, I finally got it, and I'll show that now. So I'm gonna run the server, and then I'm gonna do the solver, and somehow after a whole bunch of draws, I'm still not losing money. Doesn't seem like I'm making a ton of money. It takes a little minute. It's a little slow. Almost done here. But this is what happens. You broke the lottery system. Here's your well-deserved flag. Uh, and that's the string revealed. I believe this is a 450 point flag. A lot of fun. Interesting challenge. But yeah, that's what I wanted to demo. Thank you for your time.